Welcome to Precalculus Concept 29b underneath inverse trig functions. Today we're going to talk about the inverse cosine function, and there's only two boxes because it's pretty much the same story as the inverse sine function, only with a different domain restriction. So let's talk about it. Here's box number one. So it is the same story as we've heard with the sine function. We know that the cosine function, which I have graphed for you right here, here are 5 points just to remind you of, for our cosine function. We know that this is a function because it passes the vertical line test. However, it does not pass the horizontal line test, so therefore we cannot talk about the inverse because it doesn't pass both. Well, again, what we do is we restrict the domain. So what if I consider only from 0 to pi? If I only consider the points from 0 to pi, and again I'll do the same thing over here for you. So I'm highlighting the x-axis on both graphs. If I only consider that, well then, yes, and indeed, this function passes the vertical line test, and it also passes the horizontal line test. That makes it a one-to-one function, therefore we can speak about its inverse. So if I consider this graph over here, if I only look at this red highlighted part of the cosine curve, then if I reflect it over the line y equals x, I would get this green curve here, and this is the actual graph of the inverse cosine. It is to note a couple of things. Notice that the point 0, 1 is on the graph, therefore 1, 0 is going to be on the graph of my inverse, 1, 0. I have the point pi, -1 on the regular cosine curve. Therefore, -1, pi has to be the point on the inverse function. You also want to note that the domain and the range are switched for inputs and outputs. And it's also to note that the inverse cosine is only going to take place in quadrants number 1 and quadrants number 2. What I mean by that is, if we restrict the domain from 0 to pi, then I'm only living in quadrant 1 and quadrant 2. All of this information is going to be useful when we try to solve inverse cosine problems, which I'll do for you next. Okay, here's box 2. It's an example. We're going to find the exact value for the following. So take a look at A. When you see this statement right here, when you see this on the page, I want your brain to say this inside of your head. This means the angle in between 0 and pi whose cosine is a value of -rad3/2. So the picture that you draw for this is, here's quadrant number 1, and here's quadrant number 2. I know that cosines are going to be positive in quadrant 1 and negative in quadrant number 2. And since my value is negative, that means I must have an angle over here somewhere that's in quadrant number 2. And what I'm looking for is the point where the x-coordinate is worth -rad3/2, and that angle, theta, would have to be 5 pi over 6. Now you're going to have a unit circle filled out, so you're going to be able to easily figure out what that is. If not, you can always just draw the 30, 60, 90 triangle and figure it out. So this answer is 5 pi over 6. Let's consider B. Again, I want you, when you see this, I want you to say the angle in between 0 and pi whose cosine is a value of -1/2. So the picture that goes along with this, remember here's quadrant number 1, here is quadrant number 2. Cosines are positive in quadrant 1 and they're negative in quadrant 2. Since my value is negative, I know I'm going to have an angle that's somewhere over here that terminates in quadrant number 2. And what I'm looking for is where the x-coordinate is worth -1/2. Why the x-coordinate? Well, because I'm dealing with an inverse cosine. That happens to be true when theta is equal to 2 pi over 3. So therefore, the answer of this is worth 2 pi over 3. Okay, here's example C. Again, when you see this statement, I want you to read this off in your head. The angle in between 0 and pi, whose cosine is a value of rad2/2. So the picture that you draw, here's quadrant number 1, here's quadrant number 2. I know that inverse cosine lives between 0 and pi. I know that cosine's positive in quadrant 1 and cosine's negative in quadrant 2. And since my value is positive, I know that my angle is going to terminate in quadrant number 1. And I am looking for the angle that has an x-coordinate of rad2/2, and that angle happens to be pi over 4. So this answer is pi over